Alright, this is the Chapter 3 lecture video on orbits and gravity. Let's go right into PowerPoint. So here we have the International Space Station, an international laboratory of science that orbits the Earth every hour and a half, 90 minutes. This is in an orbit about 320 miles above Earth. We're going to talk about a couple of dead old astronomers, and the first one is Tycho Brahe, or otherwise just Tycho, and Johannes Kepler. Tycho was a very good mathematician and observationalist. What Tycho could not do, Johannes Kepler could do with math, orbits, and physics. So Tycho made observations of the night sky, decades worth, and Kepler came along and put it all together into Kepler's 3 laws of planetary motion. One of these laws states that the orbit of a planet must be an ellipse, right there. You can draw an ellipse using 2 thumbtacks, a pencil, and a piece of string, and we tie that all around together, and we can draw out a nice oval or ellipse. Kepler's second law, I like to call the pizza law, and here's why. We can draw out an orbit here on side B, and let's say that takes 1 month to occur. Over here on side A, it takes 1 month to go through the same equal area, or piece of pie, pizza, to carve out the same amount of equal area in A as we have in B. So a planet by the sun has to go fast to go through enough area as it would over here on side A when it's going slower. Planet goes slower away from the sun. Sir Isaac Newton came around and made up his works on the laws of motion, gravity, optics, and mathematics, and laid the groundwork for much of the physical sciences out there. We can demonstrate Newton's third law here with the space shuttle, and this law basically says that force is going to be equal to an equal unmatched force. Conservation of angular momentum says that when this speed skater pulls her arms in, she will start to rotate fast to conserve that angular momentum. Well, these astronauts don't look like they are in free fall, but they sure are. In the cupola module of the International Space Station, that's their window on the world. Well, here are some solar system objects, planets, and some comets that have come by, and some asteroids. And so we can see that some of the planets look almost circular, but they are actually elliptical orbits. The comets come in highly elliptical, whereas much of the asteroids are circular in their orbits. If you stand on a mountain high enough and fire a bullet fast enough, it will go in orbit around the Earth, and that speed needs to be about 17,500 miles an hour. Here is a plot of some of the many satellites in Earth orbit, and these are all tracked by the Johnson Space Center, a part of NASA in Houston, Texas. I have a colleague at another university whose research is on space debris. Well, NASA and the National Weather Service, they have modern computing power in these supercomputers. That's how we get weather forecasts and model things in the night sky and how they work. So these two mathematicians, John Couch Adams and Leverrier, share the credit for discovering the planet Neptune. And that does it for this, Chapter 3.